What if everything you thought you knew about the universe was just the tip of the iceberg? Picture standing at the edge of an ocean, staring into the waves, unaware of the vast, unexplored depths lurking beneath. That's exactly how our understanding of reality works. We've only scratched the surface. For centuries, we've lived in a world defined by three simple dimensions: length, width, and height. But what if I told you there are layers to existence so hidden, so extraordinary, they could rewrite the rules of physics as we know them? Today, we're embarking on a journey into the unknown, where the fabric of space and time twists into shapes beyond imagination. We're talking about 28 surprising dimensions in the universe, each one a doorway to mysteries that could explain everything from black holes to parallel worlds. Think about the last time you felt truly awestruck, maybe gazing at a star-filled sky or watching a documentary about the cosmos. That sense of wonder is just a glimpse of what's waiting for us. Scientists have long theorized that our universe isn't just a static stage, but a dynamic, multi-layered reality where dimensions intertwine like threads in a tapestry. Some of these dimensions are curled up so tightly they're invisible to us, while others stretch into realms where time flows backward or gravity behaves in ways that defy logic. And here's the kicker: these aren't just abstract ideas. They could hold the key to understanding why the universe expands, how matter forms, and whether we're alone in the cosmos, or just one version of ourselves among infinite others. This isn't science fiction. It's the cutting edge of human discovery, where equations on a chalkboard collide with the deepest questions about existence. So why does this matter to you? Because every breakthrough in understanding these dimensions brings us closer to answering the big questions. Where did we come from? What else is out there? And what does it mean to exist in a universe with more layers than we ever dreamed possible? Buckle up, because we're about to dive into a world where the ordinary rules don't apply, and by the end, you'll never look at reality the same way again. Let's start with the dimensions we know best, the ones that shape every moment of our lives. Length, width, and depth are the foundation of our reality, the invisible grid that gives structure to everything from the chair you're sitting on to the vast expanse of the night sky. Think about it. When you reach for a cup of coffee, your brain instinctively calculates these three dimensions to guide your hand. Without them, movement would be impossible. Objects wouldn't hold their shape, and the universe as we know it would collapse into chaos. But here's where things get interesting. These dimensions aren't just passive backdrops, they're dynamic players in the cosmic drama. Take gravity, for example. It warps the fabric of space, bending these dimensions like a trampoline under the weight of a bowling ball. Or consider time, which Einstein revealed is intertwined with space in a four-dimensional dance. Yet even this mind-bending idea is just the beginning. What if I told you these three familiar dimensions are like the first three notes of a symphony, beautiful on their own, but hinting at a far grander composition? Scientists now believe these dimensions might be hiding secrets of their own. Some theories suggest they could be curled up or folded in ways we can't perceive, like a piece of paper crumpled into a tiny ball. Others propose that what we call empty space is actually teeming with extra dimensions, too small for our eyes to see but influencing everything from the behavior of particles to the very laws of physics. It's as if we've been staring at a shadow on a cave wall, unaware of the vibrant world casting it. So why does this matter? Because every time we push the boundaries of our understanding, we uncover new possibilities. The three dimensions we take for granted might be the key to unlocking mysteries like dark energy, quantum entanglement, or even the birth of the universe itself. They're not just the stage, they're the first clue in a cosmic detective story that's far from over. And as we venture deeper into the unknown, remember this: the most extraordinary discoveries often begin by questioning the things we think we know best. Now let's step beyond the familiar 3 dimensions and into the 4th time. Unlike length, width, or depth, time feels different. We can move freely in space, but time seems to drag us forward relentlessly, like a river with no paddle. Yet Einstein's theory of relativity shattered that intuition, revealing time as just another dimension woven together with space into a single fabric called spacetime. Imagine a trampoline stretched taut. Place a bowling ball in the center and the fabric warps, creating a dip. That's how massive objects like stars and planets curve spacetime, dictating how everything moves, including the flow of time itself. This isn't just theoretical poetry. Your phone's GPS relies on this very idea. Satellites orbiting Earth experience time slightly faster than we do on the ground, thanks to our planet's gravitational pull. Without accounting for this warp in spacetime, your navigation would be off by miles within minutes. But here's where it gets wilder. If spacetime is flexible, could we bend it to our will? Science fiction loves the idea of time travel, but the math suggests it's not entirely impossible. Black holes, for instance, stretch time to its limits. Fall toward one, and to an outside observer, your clock would appear to slow to a crawl, a real-life time dilation effect. Yet time's role as the 4th dimension goes even deeper. It's the invisible hand shaping the universe's destiny. The expansion of space, the life cycles of stars, even the arrow of time, why we remember the past but not the future, all trace back to spacetime's intricate dance. Some theories even suggest that time might not be a single, unbroken line. Could there be branches, loops, or parallel streams where time flows differently? The answers might lie hidden in dimensions we've yet to uncover. So while we can't hop into a time machine, yet understanding time as a dimension reshapes our place in the cosmos. It's not just a ticking clock. It's the stage on which existence unfolds, bending under the weight of matter, stretching with the universe, and perhaps holding doors to realms we've only begun to imagine. If length, width, depth, and time form the foundation of our reality, then the 5th dimension is where physics starts bending the rules beyond recognition. Picture a world where gravity and quantum mechanics, 2 forces that stubbornly refuse to play by the same rules, finally shake hands. That's the promise of the 5th dimension, a hidden layer of reality so compact, it's like trying to spot a single thread woven into the fabric of a football field. This isn't just wild speculation. String theory, one of the most ambitious frameworks in physics, hinges on the existence of this elusive dimension. Imagine every particle in the universe isn't a tiny dot but a microscopic string vibrating at different frequencies. Just like how a guitar string can produce endless notes, these cosmic strings might generate everything from electrons to photons. But here's the catch: these strings need extra dimensions to move, like dancers requiring space to perform. The 5th dimension could be their stage, curled up so tightly that even our most powerful microscopes can't see it. Why does this matter? Because it might solve the century-old rift between Einstein's general relativity and quantum mechanics. Gravity, the force that sculpts galaxies, doesn't fit neatly into the quantum world's rulebook. But if gravity is leaking into a 5th dimension like water, seeping through cracks, it could explain why it feels so weak compared to other forces. Some scientists even suggest that dark energy, the mysterious force accelerating the universe's expansion, might be a ripple from this hidden dimension. The implications are staggering. A successful unification could give us a theory of everything, a single equation describing all forces, particles, and dimensions in one elegant framework. It would be like discovering the universe's operating manual. Yet for now, the fifth dimension remains just beyond our grasp, a shadow on the wall of a cave we're only beginning to explore. Whether it's the missing piece of the cosmic puzzle or another stepping stone to even deeper mysteries, one thing's certain: reality is far stranger than we ever imagined. What if every choice you've ever made, and every one you didn't, exist somewhere, playing out in alternate versions of reality? That's the mind-bending promise of the sixth dimension, a realm where parallel universes and alternate timelines aren't just science fiction, but a genuine possibility woven into the fabric of the cosmos. Think of it like flipping through channels on a cosmic TV, where each station shows a different version of your life. One where you took that job overseas, another where dinosaurs never went extinct, and countless others where the laws of physics themselves might be rewritten. This idea isn't just philosophical speculation. Quantum mechanics has already hinted at it with Schrödinger's famous cat, a thought experiment where a feline in a box is simultaneously alive and dead until observed. But the sixth dimension takes this further, suggesting that every quantum possibility doesn't just collapse into one outcome, it branches into its own universe. Picture a tree with infinite limbs, each sprouting from every decision, chance event, or random quantum fluctuation. Somewhere out there, a version of you might be living a life that's subtly or drastically different. The implications ripple far beyond daydreams. If the sixth dimension exists, it could explain cosmic mysteries like dark energy, or why our universe's constants are so finely tuned for life. Maybe we're just one bubble in a frothing multiverse where other universes have entirely different rules. Some might have stronger gravity, making stars burn out in moments, while others could lack atoms altogether. And here's the real kicker. If time is malleable, as Einstein showed, could these alternate timelines intersect or collide? Some theories suggest they might, leaving faint fingerprints in the cosmic microwave background, echoes of other universes brushing against our own. Yet the sixth dimension isn't just about cosmic spectacle. It forces us to confront deep questions about free will and destiny. If every possibility happens somewhere, does choice even matter, or are we just passengers in a vast, branching reality? The answers might lie in the mathematics of higher dimensions, where the fabric of existence is far richer and far stranger than we ever dared to imagine. If the sixth dimension leaves your head spinning with infinite versions of our own universe, hold on tight, because the seventh dimension is where reality truly loses the training wheels. Here, we're not just talking about alternate timelines or quantum branches of our own cosmos. This is a realm where entirely new universes bloom with their own rulebooks, where gravity might crush stars in seconds or light might never exist at all. Imagine a library where every book isn't just a different story, but written in a unique language with its own alphabet, some with letters that glow, others that dissolve when touched. That's the scale of difference we're dealing with. How could such universes even exist? The math points to something called the landscape of string theory. Think of it like a cosmic game of chance where the fundamental constants of physics, the speed of light, the strength of gravity, the charge of an electron, aren't fixed laws but random rolls of the dice. In this vast multiverse, some universes might have particles so heavy atoms could never form. Others might crackle with forces that make our electromagnetism look feeble. And here's the kicker: most of these universes would be sterile, devoid of life as we know it. We just happen to live in one where the numbers lined up perfectly for galaxies, planets, and us. But what if we could peek into these other realms? Some theories suggest that if a universe with weaker gravity brushed against ours, we might detect subtle ripples in space-time cosmic breadcrumbs leading to the unimaginable. Others propose that black holes could be portals, their singularities punching through dimensions like needles through fabric. Of course, crossing over would be catastrophic. Our atoms might unravel under alien physics the moment we arrive. Yet even the possibility reshapes our understanding of existence. Are we the rule or the rare exception in a sea of failed experiments? The seventh dimension doesn't just challenge our place in the cosmos. It forces us to ask whether the laws we consider universal are just local bylaws in a grander scheme. And if so, who or what wrote the rest? The eighth dimension is where the concept of infinity stretches beyond comprehension, not just branching timelines or alternate physics, but a plane where every conceivable universe coexists simultaneously. Imagine standing in a hall of mirrors so vast, every reflection spawns its own new hall, each with mirrors angled differently, distorting reality in unique ways. That's the eighth dimension, a cosmic repository where every possible outcome, every tweak to the laws of physics, every twist of fate exists in parallel. It's not just a multiverse, it's a megaverse, a tapestry woven from every thread of possibility. What does this mean for our understanding of existence? Consider a single decision, like turning left instead of right at a crossroads. In the sixth dimension, that might split your life into two timelines. But in the eighth, it spawns infinite variations, worlds where that left turn leads to a chance encounter with a future spouse, or a fatal accident, or even a reality where cars were never invented and you're riding a dinosaur instead. And that's just one mundane choice. Scale it up to quantum fluctuations during the Big Bang, and you've got universes where stars never ignited, where time runs backward, or where gravity repels instead of attracts. Could anything or anyone navigate this chaos? Theoretically, a civilization mastering eighth-dimensional travel wouldn't just hop between timelines. They'd curate them, plucking realities like fruits from a tree. Need a universe where light travels slower to study black holes up close? It's there. Want to explore a version of Earth where photosynthesis evolved in shades of ultraviolet? It exists, but here's the catch. The energy required to traverse this dimension would dwarf anything we can imagine. It's like trying to swim through an ocean of quicks, and while wearing lead shoes possible in theory, but laughably out of reach with our current understanding. Yet the implications ripple back to us. If every possible universe exists, does that make our lives meaningless? Quite the opposite. The eighth dimension suggests that this version of reality, the one where you're watching this video, where the constants of physics allow for galaxies and consciousness, is statistically miraculous. Among infinite failures, we're the lottery winners, and that raises an even wilder question. If everything that can exist does, could there be dimensions beyond the eighth, where even the rules of possibility get rewritten? The answer might lie in the numbers, but for now, the eighth dimension remains the ultimate frontier, a reminder that the universe's creativity has no limits. If the eighth dimension feels like the ultimate frontier of possibility, the ninth dimension shatters even that illusion, because here, universes don't just coexist, they collide, merge, and breathe new realities into existence. Picture two soap bubbles floating in the air, gently touching until their surfaces shimmer and blend into one. Now imagine that happening with entire cosmos, their fundamental laws tangling and rewriting themselves in the aftermath. This isn't just theoretical poetry. Some cosmologists believe the ninth dimension could hold answers to the universe's greatest riddles, from the explosive birth of the Big Bang to the eerie push of dark energy accelerating everything apart. Consider dark energy first, the mysterious force stretching space faster and faster. What if it's not a property of our universe at all? but the gravitational wake of another universe brushing against ours in the ninth dimension. Like ripples from a boat passing too close to shore, these higher dimensional interactions could be warping space-time in ways we're only beginning to detect. Or take the Big Bang itself. Instead of a singular explosion from nothing, what if it was the aftermath of two universes colliding in this hidden realm, their energy so immense it birthed our entire cosmic timeline? The evidence might already be hiding in plain sight. Astronomers have spotted strange, unexplained patterns in the cosmic microwave background, the afterglow of the Big Bang. Some of these anomalies, like the cold spot, a vast region of space unusually empty and frigid, could be scars from a long-ago collision with another universe. Even black holes, those enigmatic cosmic vacuum cleaners, might be more than they seem. Their singularities, points of infinite density, could be fractures in space-time, tiny portals where the ninth dimension leaks through. But the implications go beyond cosmic detective work. If universes can collide and merge, could they also communicate? Imagine a civilization in another universe, their physics utterly alien, somehow sending signals through the ninth dimension like tapping Morse code through a wall. We might never decode it, but the mere possibility redefines the search for extraterrestrial intelligence. And if new universes are born from these collisions, does that mean our own cosmos is destined to merge again, recycling itself in an endless cycle of creation and destruction? The ninth dimension doesn't just expand our idea of reality, it turns it into a living, evolving network of cosmic encounters. We might be riding the shockwaves of events we can't yet measure in a universe that's far from alone. And if that's true, then every galaxy, every star, every atom in your body could be the echo of something much bigger, a collision of worlds beyond imagination. The 10th dimension isn't just another rung on the cosmic ladder. It's the edge of the map, the point where mathematics and imagination collide so fiercely, even the boldest theories tremble. Picture standing at the shore of an infinite ocean, where every wave is a universe, every ripple a timeline, and the water itself is every possible variation of reality, all folded into a single, shimmering point. That's the 10th dimension, the ultimate mathematical framework where every what if, every could have been, and every never will be collapses into a unity so profound it defies language. This isn't abstraction for abstraction's sake. The 10th dimension emerges from the most rigorous equations in physics, like string theory's demand for extra dimensions or M-theory's vision of a membrane like multiverse. Think of it as the universe's operating system, a master code where all variables, from the strength of gravity to the charge of an electron, are just settings waiting to be adjusted. In this dimension, a hypothetical being wouldn't just travel between worlds, they'd rewrite the rules of existence with a thought. Want a universe where pi equals 4. Done, one where entropy flows backward, making shattered glasses leap back onto tables. It's already there, humming in the background. Yet for all its grandeur, the 10th dimension raises a haunting question. Is this truly the end? Some theorists argue it's the final layer, the nothing beyond, where mathematics itself runs out of road. Others whisper that it might just be the horizon of our current understanding, that beyond it there could be an 11th dimension, or a fractal infinity of higher realms we can't yet describe. After all, history has taught us that every time we declare a final frontier, the universe laughs and reveals another. The eerie beauty of the 10th dimension lies in its paradoxes. It's both everything and nothing, a cosmic singularity where all possibilities exist yet no single reality dominates. If we could perceive it, would we see the fingerprints of a creator, or just the cold, elegant machinery of self-sustaining mathematics? For now, it remains a ghost in the equations, a reminder that the universe's deepest truths might not just be stranger than we imagine, but stranger than we can imagine. And that's the real magic, not the answers we've found, but the questions we've yet to ask. Just when you thought the universe couldn't get any stranger, the 11th dimension arrives, like a hidden door in a house you've lived in for years, suddenly swinging open to reveal a room you never knew existed. This is where string theory, the grand symphony of physics, reaches its crescendo with something called M-theory. Imagine the strings we've talked about, tiny, vibrating threads that make up everything in existence, now stretching into vast, rippling membranes, or brains for short. These aren't just cosmic strings anymore, they're entire sheets of reality, floating in an 11th dimension like leaves on a pond. And if that sounds mind-bending, hold on, because this could be the missing puzzle piece that ties every force, every particle, and every dimension together into one elegant equation. So why 11 dimensions? For decades, string theorists wrestled with 5 competing versions of their own theory, each brilliant but incomplete, like different maps of the same uncharted territory. Then, in the 1990s, physicist Edward Witten had a eureka, a moment. What if all 5 were just glimpses of a single, deeper truth? Enter M-theory, where that elusive M stands for mystery, matrix, or even magic, depending on who you ask. Here, the 6 hidden dimensions we've explored don't just curl up, they become part of a sprawling landscape where brains collide, merge, and birth entire universes. Picture 2 sheets of paper floating in a breeze, touching for just a second. In that instant, the energy of their collision could spark a big bang, creating a cosmos like ours in a higher dimensional sea. But the real magic lies in unification. M-theory doesn't just reconcile string theories, it bridges the last great divide in physics, quantum mechanics, and gravity. In this framework, gravity might not be confined to our 4-dimensional spacetime at all. Instead, it could leak into the 11th dimension, explaining why it feels so weak compared to other forces. Think of it like a flashlight beam shining through a hole in a wall. What we perceive as gravity might just be a faint echo of something far grander, the evidence. It's tantalizingly indirect. Some models suggest that if our universe is a brain floating in this higher dimensional space, gravitational waves, ripples in space-time, might carry traces of collisions with other brains. Others speculate that tiny, primordial black holes could be scars from these cosmic crashes. And then there's dark matter. What if it's not a particle at all, but the gravitational tug of a parallel brain hovering just beyond our perception? Yet for all its promise, M-theory remains a cathedral built on equations, not experiments. The energy required to probe the 11th dimension is beyond anything our particle colliders can muster, trillions of times more powerful than the Large Hadron Collider. Some argue it's not even science until we can test it, but others counter that math has guided us to truths before, from black holes to the Higgs boson, long before we could see them. So what's at stake? If M-theory holds, it wouldn't just rewrite textbooks, it would redefine reality. A confirmed 11th dimension could reveal whether our universe is one of countless bubbles in a higher dimensional foam, whether time travel is mathematically possible, or if the constants of nature are truly fixed or just local bylaws in a vast multiverse. It's the ultimate cosmic detective story, and we're just turning the first page. Until then, the 11th dimension remains both a challenge and an invitation, a reminder that the universe's greatest secrets might be hiding in dimensions we've yet to imagine. If the 11th dimension feels like the peak of cosmic complexity, the 12th dimension shatters the very framework of reality, not by adding another layer, but by dissolving the boundaries we thought were unbreakable. This isn't just a dimension beyond space and time, it's a realm where those concepts cease to exist entirely. Picture trying to explain color to someone who's only ever seen in black and white. That's the challenge of grasping the 12th dimension, a plane where cause and effect, past and future, even existence and non-existence, blur into something far more fluid and alien. What could possibly exist in such a place? Some theorists suggest it's the domain of pure mathematics, a space where all possible structures and equations live, independent of physical universes. Others propose it's the substrate of consciousness itself, the hidden stage where the mind's deepest mysteries might play out. Imagine if every thought, every dream, every flicker of awareness isn't just a product of your brain, but a ripple from this dimension, like shadows cast by a light source we can't see. It's a wild idea, but not without precedent. Quantum mechanics already shows that particles behave differently when observed, as if reality responds to awareness. Could the 12th dimension be the missing link between mind and matter? Then there's the existential angle. If this dimension exists beyond time, does that mean our lives, our struggles, joys, and stories are already written in some higher sense, like ink on a page we can't perceive? Or is it the opposite, a canvas so blank, even the laws of logic don't apply? The irony is delicious. The very dimension that might explain everything could also make the concept of explanation meaningless. Science fiction loves to toy with these ideas, but the math behind them is deadly serious. Some versions of string theory hint that the 12th dimension could be the ultimate singularity, a point where all forces, all dimensions, all possible realities converge into unity. It's not a place you could visit or even comprehend, but its shadow might flicker at the edges of our understanding. When black holes evaporate, when particles entangle across galaxies, when the universe seems to remember its own rules, could we be catching glimpses of this dimension's influence? The 12th dimension doesn't just expand reality, it challenges us to rethink what reality even means. Is it the final frontier, or just the beginning of a journey into realms we've yet to name? One thing's certain, the closer we get to answering that question, the stranger the universe becomes. What if everything you see, touch, and experience is nothing more than an incredibly detailed projection, a cosmic hologram beamed from the edge of reality itself? This isn't the plot of a sci-fi movie. It's the startling premise of the holographic principle, a theory that suggests our three-dimensional universe might actually be encoded on a distant, two-dimensional surface, like a movie playing on an invisible screen. And if that's true, the 13th dimension could be the projector, the hidden realm where all the information about our existence is stored. Think of it like a credit card hologram, those shimmering images that seem to have depth when you tilt them. They're actually flat, but the way light interacts with microscopic ridges creates the illusion of three dimensions, now scaled up to the size of the cosmos. The math behind this idea comes from black holes, where physicists discovered something bizarre. The maximum amount of information a black hole can hold isn't determined by its volume, but by the area of its event horizon, the surface that traps light. It's as if all the data about what falls in gets compressed into a two-dimensional archive, like a cosmic hard drive. So how does this connect to our universe? Some scientists argue that if black holes encode information this way, maybe the entire cosmos does too. The 13th dimension could be the ultimate storage facility, a higher dimensional surface where every event, every particle, every thought is etched in unimaginable detail. Your memories, the taste of coffee, even the glow of distant galaxies, all just data points in this vast cosmic ledger. But here's where things get even wilder. If the universe is a hologram, it raises an unsettling question. Are we living in a simulation? Philosophers have toyed with this idea for centuries, but now physicists are taking it seriously. The equations suggest that the universe's information could be processed like code, with the 13th dimension acting as the server. Glitches in this system might explain quantum quirks, like particles being in two places at once until observed, as if reality is rendering details only when needed. Not everyone's convinced, of course. Critics point out that while the math is elegant, hard evidence is scarce, but intriguing clues are emerging. When physicists analyze the cosmic microwave background, the afterglow of the Big Bang, they've found patterns that resemble the pixels you'd expect from a projected reality. And experiments with quantum gravity hint that spacetime itself might be pixelated at the smallest scales, like a digital image zoomed in too far. Whether the holographic principle holds or not, it forces us to rethink what's real. If the 13th dimension is the canvas and our universe the painting, who or what holds the brush, the answer might lie not in telescopes or particle colliders, but in the very nature of information itself. After all, if reality is code, then decoding it could be the greatest scientific revolution yet to come. Fractals aren't just beautiful patterns, they might be the hidden language of the universe, written in the 14th dimension. Picture zooming into a snowflake's intricate branches and finding the same shapes repeating endlessly, no matter how close you look. Now imagine that same principle governing everything from the twist of DNA to the sprawling arms of spiral galaxies. This isn't just artistic symmetry, it's a clue that reality might be built on layers of infinite complexity, each echoing the others like a cosmic hall of mirrors. The 14th dimension takes this idea to its logical extreme, a realm where scale loses all meaning and the universe becomes a self-repeating tapestry. Think of it like a Russian nesting doll, but instead of smaller dolls inside, there are entire universes, each with its own physics, stars, and civilizations, all following the same underlying fractal blueprint. Some theories suggest this could explain eerie similarities between the microscopic and the cosmic, like how neurons in the human brain resemble the web of galaxies in the observable universe. Are these just coincidences, or is there a deeper connection woven into the fabric of existence? But here's where it gets even stranger. If the 14th dimension exists, it could redefine what we call reality. Quantum particles already behave in ways that defy classical logic, popping in and out of existence or being in multiple places at once. What if these aren't glitches but glimpses of a fractal reality, where every possibility branches into its own micro-universe? Imagine dropping a pebble into a pond and watching the ripples spread, except each ripple contains an entire pond of its own, complete with its own pebbles and ripples ad infinitum. That's the scale of recursion we're talking about. The practical implications are staggering. Fractal dimensions might hold the key to unifying quantum mechanics and gravity, two forces that stubbornly resist playing by the same rules. In a fractal universe, gravity's weakness at small scales could simply be a matter of perspective, like trying to measure the weight of a single thread in a vast tapestry. And dark matter, it might not be a mysterious substance at all, but the gravitational shadow of parallel fractal layers pressing against our own. Yet the most mind-bending possibility is this: if reality is truly fractal, then every discovery we make, every law of physics we uncover, might just be a local rule in one tiny branch of an infinite tree. The constants we think are universal, the speed of light, the charge of an electron, could be variables in a grander equation, shifting as you move between layers. It's as if we've been studying a single leaf, unaware of the forest. So is the universe a hologram, a simulation, or something even weirder? The 14th dimension doesn't just challenge our answers, it challenges the very questions we're capable of asking. And that's the real frontier, not just exploring new dimensions, but learning to think in ways that transcend them. What if the thoughts swirling through your mind right now aren't just electrical impulses in your brain, but ripples in a hidden dimension, one that connects every conscious being in the universe? Welcome to the 15th dimension, where the boundary between mind and matter blurs into something far stranger. This isn't about telepathy or sci-fi fantasy. It's about a radical idea gaining traction in physics, that consciousness itself might be a fundamental force woven into the fabric of reality like gravity or electromagnetism. Think of it like this: just as gravity warps space-time, shaping the motion of planets, could consciousness bend the rules of quantum mechanics? Experiments already show that particles behave differently when observed, as if the act of perception nudges reality into place. Some scientists, like Nobel laureate Roger Penrose, suggest this isn't a quirk but a clue. They propose that microtubules in brain cells might harness quantum vibrations, tapping into a field that permeates the 15th dimension. In this view, intuition isn't just a gut feeling, it's your brain tuning into a deeper layer of existence. Then there's déjà vu. That eerie sense of reliving a moment could be more than a memory glitch. If consciousness exists in a higher dimension where time isn't linear, these flashes might be glimpses of parallel timelines bleeding into our awareness. Or consider collective thought. Why do breakthroughs often occur simultaneously in unrelated labs? The 15th dimension could be the shared workspace, where ideas resonate across minds like whispers in a cosmic echo chamber. The implications are staggering. If consciousness is dimensional, it might explain why artificial intelligence, for all its processing power, lacks subjective experience. An AI can simulate thought, but without access to this hidden realm, it might never truly feel. It also raises spine-tingling questions about death. If the mind is more than the brain's machinery, could some form of awareness persist beyond the body, like a ripple fading into the 15th dimension's vast ocean? Of course, skeptics push back. They argue that attributing consciousness to a higher dimension risks veering into pseudoscience, a modern-day ether theory. Yet the math is tantalizing. Just as relativity and quantum mechanics once seemed outlandish, the 15th dimension might be the key to unifying mind and matter in a theory of everything. After all, if the universe can birth galaxies and life, why couldn't it also hold a dimension where thought and reality intertwine? Whether this dimension exists or not, it forces us to confront the greatest mystery of all: how a lump of gray matter inside your skull creates the vivid, sprawling universe of your inner world. And that's the real magic, not just exploring new dimensions, but realizing that the most profound frontier might be the one staring back at you in the mirror. Ancient mystics spoke of realms beyond sight, where beings of light moved between worlds, while today's physicists crunch equations, hinting at dimensions where energy transcends matter. The 16th dimension could be where these two visions collide, a crossroads between science and the sublime. Imagine a place not bound by the limits of space or time, where existence vibrates at frequencies we can't perceive, and civilizations far older than ours might operate on levels we'd mistake for magic. This isn't just speculation. Some of the brightest minds in quantum physics argue that higher dimensions could host forms of life or energy so advanced they'd appear godlike to us. Take UFO sightings, those enigmatic streaks across the sky that defy conventional explanation. While skeptics dismiss them as weather phenomena or military tech, others wonder, could these be travelers slipping through the 16th dimension? Not as physical ships, but as projections like shadows cast from a higher reality. The same might explain centuries of spiritual encounters, visions of angels, jinn, or other entities described across cultures. What if these weren't supernatural but interdimensional? A civilization tapping into our world from a plane where energy organizes itself in ways we can't yet measure. The evidence isn't just in anecdotes. Quantum entanglement, the eerie link between particles across vast distances, behaves as if information jumps dimensions, bypassing the speed of light. Then there's dark energy, the mysterious force accelerating the universe's expansion. Could it be the gravitational pull of structures in the 16th dimension, tugging at our cosmos like tides from an unseen moon? Even black holes, those cosmic enigmas, might be more than destructive voids. Their singularities could be fractures in space-time, temporary doorways where energy or intelligence passes between dimensions. But here's the twist: accessing this realm might not require spaceships or particle colliders. Consciousness itself could be the key. Meditators and psychedelic explorers report encounters with entities or landscapes that feel hyperreal, as if peeling back layers of ordinary perception. Modern experiments with DMT, a compound that alters brain chemistry, show striking similarities in these experiences across subjects, as if the mind, under the right conditions, tunes into a frequency the 16th dimension broadcasts on. Of course, the scientific community remains divided. Extraordinary claims demand extraordinary evidence, and right now, the 16th dimension lives in the realm of theory and tantalizing hints. Yet history shows us that today's heresy often becomes tomorrow's textbook. Atoms, black holes, even the Big Bang were once dismissed as fantasy. The difference now: we have the math to back up the mystery. Whether the 16th dimension holds alien civilizations, pure energy, or something beyond our vocabulary, one thing's clear: the universe is far stranger than we've dared to dream, and we're only beginning to scratch the surface. The 17th dimension might be the universe's best-kept secret, a hidden vault where dark matter, the invisible glue holding galaxies together, could be hiding in plain sight. Think of it like a game of cosmic hide and seek. We can't see dark matter, yet its gravitational fingerprints are everywhere. In the way galaxies spin faster than they should, in the way light bends around empty space, even in the very structure of the cosmos itself. So where is it? The answer could lie in a dimension so removed from our own, it's like trying to smell a color or hear a shadow. Here's the wild part: dark matter might not be missing at all. It could simply exist in a layer of reality where our senses and instruments can't reach. Picture ants crawling on a tabletop. They can move forward, backward, left, and right, but they'd have no idea you're hovering your hand just above them in the third dimension. To them, your hand is invisible, but if you pressed down, they'd feel its force. That's how dark matter might interact with our universe. It's mass-warping space-time from a dimension we can't perceive. But why the 17th dimension specifically? Some string theory models suggest that gravity, the weakest of the fundamental forces, could be leaking into higher dimensions, explaining why it feels so faint compared to electromagnetism or the strong nuclear force. If dark matter is also tied to these hidden realms, it would make sense that we only detect it through gravity's tug, like feeling the breeze from a window we can't see. The implications are staggering. If dark matter is a higher dimensional phenomenon, it could rewrite our understanding of particle physics. The Large Hadron Collider hasn't found dark matter particles because, well, they might not be particles at all, but vibrations or structures in the 17th dimension, echoing into our world as mass without light. Even more tantalizing, this could mean dark matter isn't an exotic substance but the gravitational shadow of entire parallel universes brushing against ours, their presence felt but never seen. And then there's dark energy, the mysterious force accelerating the universe's expansion. Could it be the 17th dimension stretching like a rubber sheet pulled taut, its tension driving galaxies apart? Some theories propose that dark matter and dark energy are two sides of the same coin, one holding the cosmos together, the other tearing it apart, both rooted in dimensions beyond our grasp. The search for answers is already underway. Experiments like the Laser Interferometer Gravitational Wave Observatory LIGO are listening for ripples in spacetime that might carry whispers from these hidden realms. Others are studying anomalies in the cosmic microwave background, hunting for patterns that could betray the presence of higher dimensional structures. Yet the 17th dimension isn't just a scientific puzzle, it's a philosophical mirror. If 85% of the universe's matter is invisible, existing in dimensions we can't access, what else might be lurking just beyond our perception? Civilizations, forms of energy we'd consider magic, or perhaps even stranger. What if we're the ones who are invisible to them? Our three-dimensional world just a slice of a reality far vaster and more mysterious than we ever imagined. The more we learn, the clearer it becomes. Dark matter isn't a flaw in our models. It's a signpost pointing toward dimensions we're only beginning to dream of. And if we follow it, we might not just solve a cosmic mystery, we might step into a new understanding of existence itself. Beneath the smooth surface of reality, at scales so small they make atoms look like planets, space-time itself churns and froths like a pot of boiling water. This is the quantum foam, the 18th dimension's chaotic playground, where the very fabric of existence bubbles with particles flickering in and out of being in a frenzied dance. Imagine zooming in on what appears to be empty space until you see a seething ocean of energy, where virtual particles appear from nothing, collide, and vanish in trillionths of a second. It's not science fiction. This is the bizarre world quantum mechanics predicts, and it might hold the key to understanding everything from black holes to the universe's accelerating expansion. What makes this dimension so radical? Unlike the orderly layers we've explored before, the 18th dimension isn't about hidden structures or alternate realities. It's about raw, unfiltered creation and destruction. Here, the laws of physics as we know them break down. Gravity and quantum forces clash violently, warping spacetime into fleeting tunnels and bridges. Some theorists believe these microscopic wormholes could be shortcuts linking distant parts of the cosmos, or even gateways to other dimensions. Others suggest that dark energy, the mysterious force pushing galaxies apart, might be the collective recoil of this quantum foam, like the steam rising from that boiling pot. Then there's the vacuum itself. We think of empty space as, well, empty, but in the 18th dimension, nothingness is a misnomer. The vacuum teems with activity, a roiling sea of potential where particles borrow energy from the future to exist briefly before vanishing again. This isn't just theoretical, it's measurable. The Casimir effect, where two metal plates placed incredibly close together inexplicably attract each other, happens because the quantum foam between them has less room to fluctuate than the foam outside. The plates are literally pushed together by the weight of nothingness, but the real shocker, this chaos might be the universe's creative engine. Every star, every planet, even every atom in your body could trace its origins to these quantum fluctuations. During the Big Bang, tiny ripples in the foam might have stretched across the cosmos, seeding the galaxies we see today. And if that's true, the 18th dimension isn't just a curiosity, it's the sculptor of reality itself, carving order from randomness on a scale we're only beginning to grasp. Yet for all its power, the quantum foam remains frustratingly elusive. Probing it directly would require energies beyond anything our particle colliders can muster. But indirect clues abound. Black holes, those cosmic vacuum cleaners, might be our best window. Their event horizons could magnify quantum foam effects, revealing whether space-time is smooth or pixelated at the tiniest scales. Even our search for gravitational waves ripples in space-time might one day catch echoes of this dimension's turbulence. So is the 18th dimension the universe's heartbeat, pulsing with creative chaos. Or just another layer in an infinitely complex onion. Either way, it forces us to confront a humbling truth. The solid reality we know is built on a foundation of pure frenzy. And if we ever learn to tap into that chaos, we might not just understand the cosmos, we could learn to rewrite its rules. Quantum entanglement has long been physics' greatest magic trick, particles separated by galaxies somehow mirroring each other's states instantaneously, as if space and time don't exist between them. Einstein famously called it spooky action at a distance. But what if the spookiness is just our limited perspective? The 19th dimension could be the backstage of this cosmic performance, a hidden layer where entangled particles aren't communicating faster than light but bypassing our three-dimensional reality altogether. Think of it like two ants on opposite sides of a folded piece of paper. From their flat perspective, sending a message across the sheet would take time. But if the paper bends in the third dimension, they could touch instantly by reaching upward. Similarly, entangled particles might not be transmitting information through space. They could be linked through the 19th dimension, where distance is an illusion. This would explain why their connection seems instantaneous. They're not traveling far, they're taking a shortcut through a realm we can't see. The math supports this wild idea. Quantum theory allows for non-local connections that defy classical physics, while string theory's higher dimensions provide the perfect scaffolding for such phenomena. Some models even suggest that entanglement isn't rare but ubiquitous, that every particle in the universe is subtly linked through this dimension, creating a vast, invisible network. We only notice it in lab experiments because we're isolating pairs of particles and forcing them to reveal their secret handshake. But here's where it gets truly mind-bending. If entanglement operates through the 19th dimension, it could revolutionize everything from computing to cosmology. Quantum computers already harness entanglement to perform calculations at unimaginable speeds, but understanding its dimensional roots might unlock even greater power. Imagine a future internet where data travels not through cables or satellites, but through this hidden dimension, making hacking impossible and latency non-existent. On a cosmic scale, entanglement might be the glue holding space-time itself together. The holographic principle suggests our universe could be a projection from a two-dimensional surface. But what if that surface is woven from entangled threads in the 19th dimension? Black holes, those notorious information destroyers, might not erase data but scramble it into this hidden layer, preserving it in ways we're just beginning to decipher. Even dark energy's relentless push could be the 19th dimension stretching, its tension pulling entangled particles and the space between them apart. Yet the most profound implication is philosophical. If every particle is connected through this dimension, then separation itself is an illusion. The atoms in your body might be whispering to stars billions of light years away, bound by a web older than time. It's a humbling thought. The universe isn't just stranger than we imagined. It's more intimately linked than we ever dared to dream. And as we peel back these layers, we're not just uncovering new physics. We're rediscovering an ancient truth that everything, everywhere might be part of the same extraordinary conversation. Black holes aren't just cosmic vacuum cleaners, they might be the universe's most enigmatic elevators, shuttling matter and energy into dimensions we can't fathom. The 20th dimension could be their ultimate destination, a realm where space-time doesn't just bend but shatters entirely, rewriting the rules of existence. Picture standing at the edge of Niagara Falls, watching water vanish over the edge into a misty abyss. Now imagine that waterfall is space-time itself, and the drop leads not to a river below, but to a dimension where gravity becomes infinite, time stops, and the very fabric of reality unravels. That's the heart of a black hole's singularity, the 20th dimension's doorstep. What makes this dimension so terrifyingly unique? In our familiar universe, physics has guardrails. Nothing moves faster than light. Entropy increases, cause precedes effect. But cross the event horizon and those rules crumble. Inside a black hole, space-time curves so violently that every path leads inward. No matter which direction you turn, the singularity pulls you closer, like a moth to a flame. By the time you reach the 20th dimension, the very concepts of where and when lose meaning. It's not just a place where our laws of physics break down, it's where they're erased entirely, replaced by what some theorists suggest quantum gravity might take over, stitching space-time back together in new configurations. Others propose that singularities are cosmic reset buttons, birthing new universes in their depths like seeds sprouting in the dark. The evidence is as elusive as it is tantalizing. When black holes evaporate via Hawking radiation, they leave behind cryptic clues, information scrambled into quantum noise. Some scientists believe this data isn't lost but encoded in the 20th dimension, like a message sealed in a bottle and tossed into an interdimensional ocean. Even the holographic principle hints that everything swallowed by a black hole might be preserved on its two-dimensional surface, projected from a higher dimensional blueprint. But the wildest possibility, black holes might not be the end but the beginning. If the 20th dimension exists beyond the singularity, it could be a bridge to other universes, each with its own physics. Imagine a reality where gravity pushes instead of pulls, or where time loops like a ribbon. These aren't just thought experiments. Some equations suggest that the Big Bang itself could have been a white hole, the explosive exit of matter from a black hole in another cosmos. Our entire universe might be the 20th dimension's echo, yet for all its mystery, this dimension isn't entirely beyond our reach. Gravitational waves, ripples from colliding black holes, carry faint whispers of what happens near the singularity. Future telescopes might detect echoes in these waves, subtle fingerprints of higher dimensional physics. And if we ever crack quantum gravity, we could finally read the cosmic recipe hidden in the 20th dimension's heart. So are black holes cosmic trash compactors, or the universe's most brilliant masterstroke? The answer lies in a dimension where reality itself is remade, and every piece of matter that falls in might just be ink on a page we're not yet literate enough to read. The 21st dimension could be the ultimate cosmic cradle, the hidden realm where the spark of the Big Bang first flickered into existence. Picture a single point containing all the energy, matter, and potential of our universe, but not confined to our familiar four dimensions. Instead, this singularity might have been a higher dimensional event, a rupture in the fabric of reality so profound it didn't just birth our cosmos, it could have spawned countless others. This isn't just speculation. Theories like cyclic cosmology suggest that the Big Bang wasn't a one-time explosion, but the latest in an endless cycle of universes expanding and contracting like a cosmic lung, each breath driven by forces in dimensions beyond our perception. What makes this dimension so revolutionary? Unlike the chaotic quantum foam or the entangled networks we've explored, the 21st dimension operates on a scale so vast it redefines beginnings and endings. Imagine our universe as a bubble forming in a boiling pot, except the pot is the 21st dimension, and other bubbles are constantly appearing, each with its own laws of physics. Some might collapse instantly, while others thrive for billions of years. Ours could simply be one of the lucky ones with just the right conditions for galaxies, stars, and life to emerge. The evidence lies in the echoes of the Big Bang itself. The cosmic microwave background, the afterglow of that primordial event, contains faint anomalies that some scientists interpret as bruises from collisions with other universes. These cosmic fingerprints might be traces of higher dimensional interactions, like shadows cast by neighboring realities bumping against ours in the 21st dimension. Even the universe's startling uniformity, why opposite ends of space look so similar despite never having been in contact, could hint at a pre-Big Bang phase where all points were connected in this deeper layer. But the wildest implication, if the 21st dimension is the engine of creation, then the Big Bang might not have been unique. Other universes could be budding off this dimension constantly, like apples falling from an invisible tree. Some might have stronger gravity, making stars burn out in seconds, or weaker nuclear forces, preventing atoms from ever forming. And if those universes have their own 21st dimensions, the cycle could stretch backward and forward forever, a multiverse with no true beginning or end. The search for answers is already reshaping physics. Experiments probing the earliest moments of the universe, like observations of gravitational waves from the Big Bang's first seconds, might reveal hidden patterns pointing to higher dimensional origins. Meanwhile, string theory's most ambitious models propose that the 21st dimension isn't just a backdrop but an active participant. Its geometry determining the fundamental constants of each newborn cosmos. So was our universe a random accident, or the deliberate outcome of a deeper dimensional logic? The 21st dimension doesn't just challenge our origin story, it invites us to consider that we might be one verse in an endless cosmic poem, each stanza written in the language of higher dimensions. And if that's true, the Big Bang wasn't the beginning. It was just the moment our chapter began. Light, the most fundamental messenger of the universe, might be hiding secrets far stranger than its dual nature as both particle and wave. What if the flicker of a candle, the glow of a star, even the pixels on your screen right now are all just three-dimensional shadows of something far grander? The 22nd dimension could be light's true home, a hidden layer where photons dance in ways that defy our everyday logic. Take quantum entanglement, for example. When two photons become entangled, changing one instantly affects the other, no matter how far apart they are. This isn't just magic, it's a clue. If light exists in the 22nd dimension, entanglement might not be a bizarre exception but the norm. Imagine two fireflies in a vast, dark forest. From their perspective, they're isolated. But if that forest exists in a higher dimension, they could be inches apart in a direction we can't see. Their connection isn't spooky, it's geometric. Then there's light's speed limit, the cosmic speed bump at 300,000 kilometers per second. Why this number? In our three-dimensional world, it's an unbreakable law. But in the 22nd dimension, light might not be traveling at all. It could be resonating across dimensions like a guitar string vibrating in harmony with itself. The speed we measure might just be the shadow of a deeper, instantaneous connection, a cosmic shortcut hidden in plain sight. This isn't just theoretical sleight of hand. Experiments with quantum optics have shown that photons can behave as if they're in multiple places at once, not just as probabilities but as actual, simultaneous existences. Some researchers suggest this non-locality is evidence of higher dimensional activity, where light isn't confined to our narrow slice of reality. Even the double-slit experiment, where a single photon passes through two gaps at the same time, might make perfect sense if light exists in a dimension where both and neither aren't contradictions but natural states. But the most tantalizing possibility light might be the universe's original interdimensional traveler. Ancient light from the Big Bang, still detectable as the cosmic microwave background, could carry imprints of higher dimensional physics, subtle wrinkles in its fabric pointing to realms beyond our own. Future telescopes, like the James Webb successors, might one day decode these patterns, revealing whether light is our bridge to the 22nd dimension. So the next time you flip a switch or gaze at the stars, remember, the light you're seeing might not just illuminate your world. It could be whispering secrets from a dimension where the rules are written in a language we're only beginning to understand. If the 22nd dimension redefines how we see light, the 23rd shatters our understanding of reality altogether, because this isn't just another layer of existence. It's the anti-dimension, a shadow realm where the rules invert, matter unravels, and even time might flow backward. Picture a mirror not just reflecting your image, but an entire parallel cosmos where gravity repels, particles have negative mass, and the very fabric of space pulses with a dark, counterbalancing energy. This isn't science fiction. Theoretical physics hints that for every dimension we know, there could be an equal and opposite counterpart, lurking just beyond the edge of perception. Take antimatter, for instance. Every particle we're familiar with, electrons, protons, quarks, has a doppelganger with opposite charge. When matter and antimatter meet, they annihilate in a burst of pure energy. But what if antimatter isn't just a quirky twin? It might be the 23rd dimension's leakage into our world, a whisper from a realm where positive becomes negative and vice versa. Some models suggest that dark energy, the mysterious force accelerating the universe's expansion, could be the gravitational push of this anti-dimension, like two magnets repelling each other through a hidden field. Then there's the mind-bending possibility of dimensional collisions. If our universe's dimensions ever brushed against their anti-counterparts, the results would make supernova look like firecrackers. Imagine two soap bubbles, one filled with matter, the other with antimatter, grazing each other in a higher dimensional space. The contact point could ignite a chain reaction rewriting physics itself, creating regions where time loops into knots, gravity flips direction, or even pockets of negative space where objects subtract from reality instead of adding to it. The evidence for this is speculative but tantalizing. Cosmic voids, vast, eerily empty regions of space where galaxies refuse to form, might not be accidents. They could be scars from ancient collisions with the anti-dimension, zones where the usual rules of physics were erased. Even quantum fluctuations, those tiny particles popping in and out of existence, might be echoes of this deeper struggle, like waves from a distant storm. But the real question isn't just whether the 23rd dimension exists, it's what happens if we ever learn to touch it. Harnessing anti-dimensional energy could unlock power sources beyond fusion, or propulsion systems that bend spacetime in ways that make warp drives look primitive. Of course, the risks are just as staggering. A misstep could unravel atoms like loose threads or crack spacetime open like an eggshell. So is the 23rd dimension the universe's balancing act, a hidden counterweight keeping reality stable? Or is it a cosmic powder keg, waiting for the spark that reshapes existence? Either way, one thing's clear: the deeper we probe, the more the universe reveals itself not as a single stage, but as an endless hall of mirrors, each reflection stranger and more spectacular than the last. Sound isn't just something we hear, it might be the universe's hidden language, vibrating through dimensions we can't perceive. While we're used to sound waves traveling through air, water, or even solid objects, the 24th dimension could be where these vibrations take on a cosmic scale, carrying messages far beyond the limits of our ears. Picture the deep, resonant hum of a black hole merger, detected as gravitational waves or the eerie whispers of cosmic microwave background radiation. What if these aren't just random noise, but echoes from a dimension where sound operates in ways we can't yet comprehend? Consider gravitational waves' first ripples in spacetime caused by cataclysmic events like colliding neutron stars. These waves aren't sound in the traditional sense, but when converted into audio frequencies, they produce eerie chirps and rumbles. Scientists have even called them the sounds of the universe, but here's the twist: gravitational waves don't need a medium like air to travel. They move through spacetime itself, warping the fabric of reality as they go. Could this mean they're tapping into the 24th dimension, a realm where vibrations don't rely on matter but resonate through the underlying structure of existence? Then there's the mysterious cosmic hum, a low-frequency signal detected by pulsar timing arrays. Some theories suggest it's the collective chorus of supermassive black holes merging across the universe, while others propose it's evidence of primordial gravitational waves from the Big Bang. But what if it's something deeper, a harmonic signature of the 24th dimension, where sound waves don't decay but persist, humming in the background of reality like a never-ending chord? Even quantum physics hints at this possibility. At the smallest scales, particles exhibit wave-like behavior, vibrating at specific frequencies. String theory takes this further, suggesting that all particles are tiny, vibrating strings, essentially the universe's fundamental notes. If these strings exist in higher dimensions, their vibrations could produce a symphony we're only beginning to detect, with the 24th dimension acting as the concert hall where the music of matter itself is composed. So why can't we hear these cosmic sounds directly? Our ears are tuned to a narrow range of frequencies, just as our eyes see only a sliver of the electromagnetic spectrum. The universe might be singing in dimensions our biology isn't equipped to perceive, like a dog whistle pitched too high for human ears, but filled with meaning all the same. Future experiments like more sensitive gravitational wave detectors or quantum resonance scanners might one day tune into these hidden frequencies, revealing whether the cosmos is silent or if we've simply been deaf to its song. The implications stretch beyond curiosity. If sound operates differently in the 24th dimension, could we harness it? Imagine communication systems that transmit data through higher dimensional vibrations, bypassing the speed of light. Or medical technologies that detect diseases by listening to the resonant frequencies of cells, tuned into dimensions where subtle imbalances become audible. Even the search for extraterrestrial intelligence might need an upgrade. What if alien civilizations aren't broadcasting radio waves, but dimensional harmonies we've yet to decode? The 24th dimension doesn't just challenge our understanding of sound, it redefines what it means to listen. From the deepest hum of black holes to the quantum vibrations of atoms, the universe might not be the silent void we imagine. It could be a chorus, a cacophony, a melody playing in dimensions we're only beginning to sense. And if we learn to hear it, we might discover that reality isn't just something we see or touch. It's something we can finally, truly hear. What if every thought you've ever had, every fleeting idea, every vivid dream wasn't just a spark in your brain, but a ripple in a hidden dimension that connects all consciousness? Welcome to the 25th dimension, a realm where the energy of thought might transcend the limits of space and time, weaving minds together in ways that defy conventional science. Imagine standing in a crowded room and suddenly knowing what a stranger is about to say, or dreaming an event before it happens, not as déjà vu, but as a genuine glimpse into a dimension where past, present, and future thoughts coexist. This isn't just paranormal speculation. Cutting-edge experiments in neuroscience and quantum physics are starting to suggest that consciousness might operate in dimensions beyond the four we experience daily. Take telepathy, for instance. While mainstream science dismisses it as fantasy, studies in quantum entanglement show that particles can instantaneously influence each other across vast distances. If subatomic particles can communicate faster than light, could entangled minds do the same? In the 25th dimension, thoughts might not be confined to individual brains but exist as shared vibrations, like tuning forks resonating at the same frequency across a hidden field. Research into collective consciousness hints at this possibility. When groups meditate or focus on the same intention, measurable changes occur in random event generators, machines designed to spit out unpredictable numbers. Somehow, focused thought seems to bend probability, as if the 25th dimension is a canvas where mental energy leaves subtle brushstrokes. Then there's precognition, the eerie phenomenon of knowing future events before they unfold. In labs worldwide, subjects hooked to EEG machines have shown brain activity spike seconds before seeing emotionally charged images, as if their neurons are reacting to stimuli that haven't technically happened yet. If time in the 25th dimension isn't linear but stacked like pages in a book, these flashes could be the mind reading ahead. Even dreams might tap into this dimension. Consider the countless reports of people dreaming about disasters or personal tragedies before they occur, down to chillingly precise details. Could these be accidental dips into a higher dimensional stream of information? The implications are staggering. If thoughts exist in the 25th dimension, it could explain why creativity often feels like downloading ideas from nowhere, or why twins separated at birth sometimes develop identical mannerisms. It might even redefine mental health. Depression or anxiety could be imbalances not just in brain chemistry, but in our connection to this dimension's energetic field. And if thoughts can traverse time, could sending a message to your past or future self be possible? Some innovators already claim breakthroughs came from future memories, as if their inventions existed in the 25th dimension before they were physically realized. Of course, skeptics argue that these phenomena are just coincidences or wishful thinking. But as brain scanning tech advances, we're discovering that thoughts generate measurable electromagnetic fields, energy that, in theory, could propagate through higher dimensions like radio waves through air. Future experiments might look for thought interference patterns between isolated subjects or hunt for neural signatures of precognition in quantum systems. The line between science and science fiction is blurring fast. So is the 25th dimension, the missing link between mind and cosmos, a hidden layer where creativity, intuition, and even destiny intertwine. Whether it's proven or not, one thing's certain: the power of thought has always been humanity's greatest mystery and its greatest tool. And if we ever learn to navigate this dimension intentionally, we might not just understand consciousness. We could rewrite it. Dreams have always been the mind's uncharted frontier, a place where logic bends, time warps, and the impossible feels as real as the ground beneath your feet. But what if these nightly adventures aren't just random firings of neurons? What if they're fleeting visits to the 26th dimension, a realm where the rules of our waking world dissolve into something far more fluid and mysterious? Picture this: you're flying over a cityscape that defies gravity, or having a conversation with someone who's been gone for years. In the dream, it feels utterly real, even as your waking mind dismisses it as fantasy. But what if that surreal clarity is a clue, a glimpse into a dimension where thoughts shape reality instantaneously, where the boundaries between self and world blur into nothingness? Lucid dreaming offers some of the most compelling hints. Those rare moments when you realize you're dreaming and suddenly gain control aren't just psychological quirks. They might be brief awakenings to the 26th dimension's true nature, where consciousness isn't tethered to the body but free to explore. Studies show that during lucid dreams, brain activity mirrors waking awareness in some regions while diving into deep, imaginative states in others. It's as if the mind is straddling two realities, one foot in our world and the other in a dimension where intention rewrites the rules. And what about shared dreams? Countless people report dreaming of the same places or events as loved ones, sometimes down to eerie details, coincidence, or proof that in the 26th dimension, minds can meet outside the confines of space and time. Then there's astral projection, the controversial phenomenon where individuals claim to leave their bodies and traverse realms beyond the physical. Skeptics dismiss it as hallucination, but the descriptions are strikingly consistent. Silver cords tethering the traveler to their body, landscapes vibrating with unfamiliar energy, encounters with entities that feel more real than memory. If the 26th dimension exists, it could explain these experiences as accidental crossings, moments when the brain's filters weaken, allowing consciousness to slip into a higher dimensional plane. Even modern physics toys with this idea. Quantum theories suggest that at the smallest scales, particles pop in and out of existence, borrowing energy from unseen dimensions. Could the mind, under the right conditions, do the same? The implications ripple far beyond bedtime stories. If dreams are dimensional journeys, they might hold untapped potential. Ancient cultures saw them as portals for healing or prophecy, while modern innovators credit dreams with breakthroughs from Einstein's theory of relativity to Paul McCartney's melody for Yesterday. Maybe these flashes of insight aren't just subconscious processing but data pulled from the 26th dimension, where ideas exist as tangible things waiting to be discovered. Future tech might even harness this. Imagine devices that stabilize dream states, allowing scientists to map this dimension like astronomers chart the cosmos, or therapies that heal trauma by rewriting its script in the malleable reality of dreams. Of course, the 26th dimension isn't just about human experience. If it's a fundamental layer of reality, it could explain cosmic mysteries too. Dark matter's invisible grip on galaxies, the universe's accelerating expansion. What if these are echoes of interactions with this dreamlike dimension, where gravity and energy behave in ways our math can't yet describe? Even black holes, those cosmic enigmas, might be gateways where the 26th dimension bleeds into ours, warping space-time into something unrecognizable. So the next time you wake up with a gasp, heart racing from a dream that felt too real to dismiss, ask yourself, was it just your brain's screensaver, or did you, for one brief moment, wander a dimension where the only limit is the imagination itself? The answer could redefine not just sleep, but the very nature of reality. Fate has always been the universe's greatest riddle. Do we carve our own paths? Or are we walking roads laid out long before we took our first steps? The 27th dimension might hold the answer, a hidden realm where every decision, every chance encounter, every twist of destiny is etched into the fabric of reality like ink on an endless scroll. Think of it as a cosmic library, but instead of books, its shelves hold infinite variations of your life, each volume detailing a different choice you could have made, a different future you might have lived. This isn't just philosophical musing. Quantum mechanics and string theory are now flirting with the idea that fate might not be an illusion, but a higher dimensional structure we're only beginning to glimpse. Consider the double-slit experiment, where particles behave differently when observed, as if the act of measurement forces reality to choose an outcome. What if that choice isn't random but predetermined in the 27th dimension? Imagine a river splitting into countless streams, each representing a possible future. From our limited perspective, we see only the branch we're floating down, unaware that every fork was mapped out in a dimension where time isn't a line but a sprawling, interconnected web. Ancient cultures sensed this. The Norse spoke of the weird, a tapestry woven by the Norns. The Greeks had the moirai, spinning threads of destiny. Could these myths be intuitive grasps at a truth science is now uncovering? But here's the twist. Even if fate is written in the 27th dimension, it might not negate free will. Think of a video game. The code determines all possible outcomes, but the player's choices still matter. Similarly, this dimension could host every potential version of events, while our consciousness, our will, selects the path. This superdeterminism would explain eerie synchronicities, those moments when life feels scripted without reducing us to puppets. After all, a script is meaningless without actors to bring it to life. The evidence is as subtle as it is compelling. Studies in decision neuroscience show that our brains often commit to choices seconds before we're consciously aware of them, as if our free will is catching up to a decision already made in deeper layers of reality. Even entropy, the universe's arrow of time, might hint at this. The past feels fixed because it's crystallized in higher dimensions, while the future remains fluid, a paradox that could resolve if the 27th dimension acts as a scaffold, guiding probabilities without eliminating spontaneity. So is destiny real? The answer might depend on where you're standing. From our three-dimensional view, every choice feels weighty, every moment ripe with possibility. But from the vantage of the 27th dimension, those choices could be threads in a grander design, one where chaos and order dance in perfect, predestined harmony. Whether that's comforting or unsettling, one thing's certain: the universe's script is far richer and far stranger than we ever imagined. The 28th dimension isn't just another rung on the cosmic ladder. It's the final frontier of imagination, a realm so far beyond human comprehension that even the boldest theories falter at its threshold. Picture standing at the edge of an endless abyss, peering into a darkness so profound it redefines the word unknown. This isn't merely a dimension where the laws of physics break down. It's where the very concept of laws dissolves into pure potential. Some theorists argue it's the source code of existence, the primordial canvas upon which all other dimensions are painted. Others whisper it might be the opposite, an all-consuming void, the universe's ultimate reset button waiting to be pressed. Consider the concept of creation itself. Every major cosmological model, from the Big Bang to cyclic universes, traces back to a singular origin, a moment when everything sprang from nothing. But what if that nothing wasn't empty? What if it was the 28th dimension, a realm where time, space, and energy don't just cease to exist but transcend existence as we understand it? Ancient myths spoke of chaos before creation, a formless void teeming with latent possibility. Modern physics, in its own way, echoes this. Quantum fluctuations suggest that even a perfect vacuum isn't truly empty but seethes with virtual particles appearing and vanishing. Could the 28th dimension be the ultimate vacuum, the wellspring from which universes bubble forth like droplets on a boiling surface? Then there's the chilling alternative, annihilation. If the 28th dimension is the end rather than the beginning, it might explain dark energy's relentless push to accelerate the universe's expansion. Perhaps this isn't just random cosmic behavior, but the slow, inevitable pull of everything toward this ultimate abyss, a gravitational tide dragging all of reality into a dimensional maw. Black holes offer a glimpse of this process on a smaller scale, their singularities crushing matter into oblivion. But the 28th dimension wouldn't just destroy, it might unmake, erasing not just objects but the very framework of reality, like a file deleted from a cosmic hard drive. Yet the most tantalizing possibility isn't destruction or creation, it's intelligence. Could the 28th dimension be the domain of a consciousness so vast, our entire universe is but a fleeting thought in its mind? The idea isn't as far-fetched as it sounds. Holographic theory suggests our reality might be a projection from a two-dimensional boundary. Scale that up, and our cosmos could be the mental construct of an entity operating in dimensions beyond our counting. Even mathematics hints at this. Gödel's incompleteness theorem proves that any logical system will always contain truths it can't prove from within itself. What if the 28th dimension is the outside, where those unprovable truths reside, the vantage point from which all mysteries, from dark matter to consciousness, finally make sense? Then again, perhaps the truth is simpler and stranger. The 28th dimension might not be a place or a force, but a state beyond language, where all dualities, creation and destruction, order and chaos, something and nothing fuse into a unity that human brains simply can't process. It's the cosmic punchline to a joke we're not yet equipped to understand. The moment we think we've grasped it, it slips away, leaving only awe in its wake. So is the 28th dimension the answer to everything, or the reminder that some questions have no answers? It stands as both the universe's grandest secret and its most humbling lesson. No matter how far we reach, there will always be horizons beyond our grasp. And maybe that's the point, not to solve the mystery, but to live in its wonder. The hunt for higher dimensions isn't just a scientific challenge. It's like trying to decode a message written in invisible ink. We've got compelling theories, elegant equations, and even glimpses of their effects on our universe, but concrete proof, that's where things get messy. The first hurdle is sheer scale. Many higher dimensions are thought to be compactified, curled up smaller than a quark, trillions of times tinier than anything our microscopes can resolve. Imagine trying to spot a tennis ball on the surface of Pluto with a backyard telescope. That's roughly the level of difficulty physicists face when probing these hidden realms. Then there's the energy problem. To directly observe higher dimensions, we'd need particle colliders with energies millions of times more powerful than the Large Hadron Collider. Current tech can't even come close. It's like trying to crack open a walnut with a feather. The tools simply aren't up to the task. Some researchers hope that cosmic rays, ultra-high energy particles from deep space, might accidentally reveal dimensional leaks, but spotting these needle-in-a-haystack events requires detectors the size of cities. But the toughest roadblock might be reality itself. Higher dimensions could operate under physics so alien, our instruments aren't just inadequate, they're conceptually mismatched. Think about a fish trying to understand rain. The water's surface distorts under each droplet, but to the fish, these ripples would seem like random, inexplicable events. Similarly, if gravity leaks into higher dimensions or particles phase between layers, we might be seeing the ripples without comprehending their source. Even our language struggles here. Words like dimension or space come loaded with three-dimensional assumptions, making it harder to conceptualize realities where, say, time loops back on itself or causality runs sideways. Yet hope isn't lost. Indirect evidence is piling up. The perplexing behavior of quantum particles, anomalies in gravitational waves, even the universe's accelerating expansion. Any of these could be breadcrumbs leading to higher dimensions. Future telescopes scanning the cosmic microwave background might find fingerprints of colliding universes, while quantum computers could simulate dimensional interactions beyond our lab capabilities. The universe loves its secrets, but every locked door has a key. We just need to keep searching and stay open to the possibility that the answers might rewrite not just science, but our very place in the cosmos. If higher dimensions are real, they don't just reshape our understanding of physics, they force us to reimagine what it means to be human. Suddenly, the cosmos isn't just a vast, indifferent expanse. It's a layered reality where our three-dimensional lives might be as limited as a flatlander's view of a sphere. Think of an ant crawling across a painting. It senses colors and textures, but has no concept of the artist's brushstrokes or the gallery beyond. Are we, in our four-dimensional space-time, just as oblivious to the full masterpiece? This isn't just about scientific curiosity. The existence of higher dimensions could answer or complicate humanity's oldest questions. Take the soul, for instance. For millennia, cultures have described it as an immaterial essence, something beyond the physical body. Could that beyond be literal? If consciousness operates in higher dimensions, as some theories suggest, the soul might not be a metaphor but a higher dimensional structure, woven into the fabric of reality in ways our brains can't fully perceive. Near-death experiences, where people report floating outside their bodies or seeing luminous beings, might not be hallucinations but fleeting glimpses into these deeper layers. Even memory, that fragile web of neural connections, could have a dimensional component. Why else do we sometimes remember events that never happened, as if accessing alternate timelines? Then there's free will. In a universe where every possible choice branches into parallel dimensions, are we truly making decisions or just riding the currents of a predetermined multiverse? The answer might lie in perspective. From our limited view, choices feel weighty and real, but from a higher dimensional vantage, they could be like tributaries in a river, separate yet part of the same flow. This doesn't negate agency, it reframes it. Imagine a novelist crafting a character. The character's choices matter within the story, even though the author sees all possible outcomes. In that sense, higher dimensions might not erase meaning, they could expand it, making every action part of a grander, interconnected narrative. Purpose, too, takes on new dimensions literally. If our universe is one of countless bubbles in a higher dimensional foam, does that make life insignificant or astonishingly rare? Statistically, most universes would be sterile, their physics hostile to atoms, let alone organisms. The fact that we exist at all in a cosmos fine-tuned for complexity suggests either unimaginable luck or something more provocative. That life isn't an accident but a feature of reality's deepest architecture. Some theories even propose that consciousness is a fundamental force, like gravity, woven into higher dimensions to observe and shape the universe into existence. It's a modern spin on an ancient idea that the cosmos knows itself through us, but the most humbling implication is existential. If we're shadows on a higher dimensional wall, as Plato's cave allegory hinted, then our entire reality might be a projection, a simplified rendering of something far richer. Yet shadows aren't illusions, they're evidence of light and form. Similarly, our lives could be both limited and profoundly connected to something greater. The atoms in your body were forged in stars, entangled with particles across the galaxy, and perhaps in ways we're only beginning to glimpse, resonating with dimensions beyond perception. So are we prisoners of our limited senses, or pioneers on the edge of a dimensional frontier? The answer might lie in how we choose to see ourselves not as isolated specks, but as participants in a reality so vast, its full dimensions are still waiting to be discovered. And that changes everything.